running Pandas on GPU and taking it to the moon. Pandas can handle a significant amount of data and process it most efficiently. But at the core, it is still running on CPUs. Parallel processing can be achieved to speed up the process, but it is still not efficient to handle large amounts of data. GPU is a better option to process huge amounts of data on the fly. GPUs were primarily used for gaming and extensive video rendering work. Researchers found its potential in boosting deep learning algorithms, and currently, most of the big projects rely on GPU support. In this video, we will explore Nvidia Rapids, which is an open source library for executing data science pipelines entirely on GPUs. I will compare the normal Pandas performance in comparison to GPU data frames. We will be testing out this library in Google Colab as it provides free GPU support. Step 1. Enable GPU runtime. First, tap on the runtime option from the menu bar and select Change Runtime Type. Next, select GPU at the hardware accelerator. Step 2. Check graphics card. Currently, CUDA, which makes it possible to run general-purpose programming on GPUs, is only available for Nvidia graphics cards. Although Google Colab allocates Nvidia or Tesla-based GPUs, Rapids only supports P4, P100, T4, or V100 GPUs in Google Colab. You can use this to confirm by running this command. Step 3. Fetch the Rapids Colab installation files. Step 4. Updating Colab environment files and kernel restart. The following commands will update the existing Colab files and restart the kernel. Your session will crash after this command, but it will restart automatically. Step 5. Install Conda Colab. This is the last time the session will crash and the kernel restarts. After the restart, you can check if the installation was successful by running this command. Step 6. Install Rapids. The last setup command and the most time taking, it could be about 15 minutes approximately, is for installing the Rapids on the Colab instance and copying the files in the current working directory. A few moments later, now we're all set to test out the GPU performances. Okay. To test out the full potential of the GPUs, we will create a fairly large data frame, QDF data frame with a size of 10 million rows and 2 columns. QDF is a Python GPU data frame. It is built as a mirror to Pandas data frame and has almost every function that Pandas offer. It can be used as a replacement for Pandas and it will execute all operations in GPU memory. The creation time for these data frames is almost the same because we used a NumPy array instead of lists. If lists were used, a significant difference is observed. Performing operations. Let's do some operations on these data frames to capture the speed difference and check if GPU really busts the performance or not. First, logarithmic operation. Applying NumPy log function on one of the columns of both data frames and doing it over 10 loops to get the best average. As you can see, that applying the logarithmic function on GPU data frame yield results in approximately 20 milliseconds versus 120 milliseconds for the CPU case. This is the difference we expect in GPU-based processing. All the processes are efficient and done in high-performance memory. Square operation. Applying NumPy square function on one of the columns of both types and data frames. Here in execution time, we have almost 10-fold difference in performance. The CPU case took approximately 75.4 milliseconds to run, while the GPU case took the whopping 8.65 milliseconds. Converting integer data type to string. To amaze you even more, let's convert the column 1 on both types of data frames, which contains integer values ranging from 0 to 10 million, to string type values, which is an object. This execution difference in terms of speed matters in real-world projects where quick data ingestion and prediction are required. Conclusion. In all terms, GPU-based processing is far better than CPU-based processing. Libraries like Pandas, sklearn play an important role in data science lifecycle. When the size of data increases, CPU-based processing becomes slower and a faster alternative is needed. GPUs fill this gap.